Hi guys. So I just wanted to get on here and kind of explain some of the stuff about Newton's laws of motion. So so far we've kind of talked about how objects move. We've talked about displacement and velocity and acceleration. We haven't really talked about the why. And so that is kind of where we get into Newton's laws of motion. So really I'm going to talk to you today is I'm going to go through really quickly the three laws of motion, and then we're going to spend some time specifically on the second law of motion, figuring out how we can calculate acceleration based on forces. Okay, so let's look at this first law of motion really quickly. Okay, so this is Newton's first law, is known as the law of inertia. So this basically is how we get objects to start moving or how we cause them to have a change in motion. So we're talking here about like an object that still is going to remain still, or an object that's moving is going to remain moving unless there's some kind of force that acts on it. So that's the Newton's first law of motion. This is basically the reason that you have to wear a seatbelt when you're in the car, because if something hits your car, okay, so that's a different object than you inside of the car. So if you're traveling at 80 miles an hour and something hits the car and it stops it, you are going to continue moving at 80 miles an hour unless something causes you to stop. So that's why seatbelts are important, is because of Newton's first law of motion. All right, so inertia is the tendency of an object to resist a change in motion. So that's, again, so with that ball in this picture, you can see the ball right here. You have gravity that's acting on it, friction that's acting against it. If you kick it, those two forces, the reason that object is going to continue or is going to stop moving is because of gravity is going to push it down, and friction is going to be pushing against it once it hits the ground. If gravity and friction didn't exist, when you kicked that ball, it would continue moving forever and ever and ever. So that's another reason that like when we send things into space, because there's no gravity in space and there's no atmosphere, there's no friction. So you're essentially working in a vacuum. So we can make things orbit because there's nothing because of Newton's law of motion, because there's nothing that's resisting the change in that motion. Okay. Newton's second law is where we're going to be spending most of our time today. And this is probably going to be broken up into a couple of videos because the maximum I can do on this app is 5 minutes. So if it cuts me off, I'll just create another one. So Newton's second law of motion is basically how we get acceleration. So force creates acceleration. And so F equals mass times acceleration. So the amount of force that's applied to an object is how we get acceleration. So the more acceleration you have, the more force has to be applied. And that works in both directions, positive acceleration and negative acceleration. The faster we want something to slow down, the more force we have to apply to it. So acceleration is determined by the size of the force and also the mass of the object. So this is where, for example, if you have, if my 2-year-old goes and kicks this soccer ball versus me kicking the soccer ball, I have a larger mass, and so I'm going to be able to accelerate that soccer ball much faster than my 2-year-old is. Also, if I go and I kick something that's very large, that has like a much larger mass, it's not going to have as much acceleration as something like a small soccer ball. So both of these factors, both force and mass, are going to affect acceleration. Okay, let's look at Newton's. Okay, hold on. Let's practice this for a second. Okay, so this is where we talk a little bit about force equals mass times acceleration. Okay, so a force of 20 newtons acts upon a 5-kilogram object, and we're going to calculate the acceleration. Okay, so I've got I don't know if you can see this right here, but I've got my little sheet. So I'm going to write on this, and then I'm going to show you what it looks like. Okay, so the formula for Newton's second law is F equals M times A. Okay, so can you see that's what it looks like right there? So we're working with 20 newtons of force, and the mass of our object is 5 kilograms. So we want to know, we're looking for A. We want to know what the acceleration of that object is going to be. So we're going to take this over here. We're going to take 20 divided by 5 to get the acceleration. So 20 divided by 5 is going to give us an acceleration of 4. Okay, so we're going to divide by 5 kilograms on both sides, and that's going to give us an acceleration of 4 meters per second squared. So you can see that right there. That means that for every second, we're going to be increasing our speed by 4 meters per second if we apply 20 newtons of force to that object.